Hello there, our wonderful and esteemed viewers on this favorite mathematics YouTube channel, Mathematics by Abuzina. That special channel created for you and I to come together to demystify mathematics and tackle the age-long phobia associated with this all-important subject, one topic at a time. Thanks so much for staying tuned. God bless you. In the last videos, we have looked at the concept of binomial expansion, and we looked precisely at the very first video on binomial expansion by explaining the concept of the Pascal's triangle. It was followed by the video on the binomial expansion formula, which was just our immediate last video. Today, we are continuing in the topic binomial expansion still, but this time around, looking at how to evaluate numerical expressions using the binomial expansion idea. So we are continuing by looking at this example here. Expand 1 plus x to the power of 5. Then b, hence evaluate 1.03 to the power of 5. Correct? So 4 decimal places. Now, this is a typical examination question in the theory, that's essay type exam. The part A is to expand 1 plus x to the power of 5. But more importantly, part B, I'm going to emphasize 2 things here. The word hence is often used in questions like this. They are asked to solve a question and B now says hence evaluate. The fact that the word hence is used there, it necessarily means that you must use the answer gotten in the previous step to solve this particular problem. Necessarily, it could be alternative. If, however, the question is framed in such a way that it is written as hence or otherwise. So the fact that you are given that or otherwise is an option, an alternative that you might not necessarily use the option, the solution gotten previously. So get to know the differences. That's one. Then two, often avoiding mistake that students also make or candidates make in an exam is not to solve their questions correct to the given degree of accuracy. Here, you have to solve correct to 4dp. So you must necessarily leave the answer in 4dp. That's 4 decimal places. So after thinking it for those two, let's go in and solve this problem. We've got 1 plus x all to the power of 5. You can choose to either solve this question using the binomial expansion formula or using Pascal's triangle, as it has not been told here what exactly you must use. So if I choose to use the binomial, I'm going to have this 1 power 5 plus 5, 1 power 4, and then x power 1 plus 5, then 4 over 2 factorial, then you have 1 power 3, then x power 2. Then you have 5, 4, 3 over 3 factorial, 1 squared x cubed plus 5, 4, 3, 2 over 4 factorial, then 1 x power 4, and lastly just x power 5. This is the binomial expansion formula applied to this question. So here we have 1 plus 5x. This is 5 by 4 is 20. 2 factorial is still 2. So 3 in 20 is 10. I've got 10 then x squared. 3 factorial means 3 times 2 times 1, which is 6. So 6 in 12 is this. That's 2 times 5. 10 power x cubed. Then plus the next one here, we have 4 factorial is 4 times 3 times 2 times 1, which cancels out the numerator 4, 3, 2, 1. We are left with just 5. So you have 5x power 4. And of course, lastly, x power 5. So this is the expansion for 1 plus x to the power of 5. Using the binomial expansion formula, of course. So I'm done with part A. Now part B says hence evaluate 1.03 to the power of 5. So what I meant to do here is to simply equate the content of these two brackets so as to know the real value or x. So by so doing, I'm going to have 1 plus x equals 1.03. Therefore, x is 1.03 minus 1, which is 0.03. That's my value of x. That means that 1.03 to the power of 5, which is required, is simply writing this out with 1 plus 0.03 to the power of 5. So that when I liken this to the expansion, I'm just going to pick x as having the value 0.03 in its binomial expansion. Then this becomes 1 plus 5 times 0.03 plus 10 times 0.03 squared plus 10 again, 0.03 cubed plus 5, 0.03 4 plus 0.03 power 5. So I simply substituted 0.03 in lieu of the x's in the expansion. And at this point, what you need to do is to use your calculator. When you compute, we are going to have, so 4 decimal places 1.1593 to 4 decimal places, which is pretty straightforward. So all you need to do is just take note of each step without making mistakes. Okay. Then we take our next question, which is going to be slightly different because of the involvement of negative. So here, I'm going to expand 1 minus 2x to the power of 4, and then again evaluate 1.98 to the power of 4, correct to 4 decimal places. Pretty much the same way. Now, so 1 minus 2x to the power of 4. I can choose to use my Pascal's triangle here. Power 4 is going to be having 1, 4, 6, 4, and 1. That's what's power 4. Because we have, remember, we have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So power 4 is going to be 1, 4, 6, 4, 1. So by using Pascal's triangle, we're going to have coefficients 1, 4, 6, 4, 1. So I'm going to have then 1 raised to power 4, then plus 4. That's the next coefficient. 1 power 3 this time around. Then take note of the power of the sign minus there. Then I'm going to have 6, 1, 2, minus 2x power 2. Then 4. 1 is 1 here, minus 2x power 3. Then lastly, minus 2x power 4. So we got our coefficients 1, 4, 6, 4, 1. And for the powers, while the first value is decreasing, 4, 3, 2, 1, 0. Second value is picking up 0 here, 1, 2, 3, 4. You may need to look back at our video on Pascal's triangle for a clear understanding of this. So let's move on. I'm going to have here 1. 1 cube is just 1. So this is going to be minus 8x. This minus 2 squared is 4 times 6. That's plus 24x squared. Minus 2 cubed is minus 8 times 4. Minus 32x cubed. So minus 2 to the power of 4 is simply plus 16x power 4. Hence, expansion of 1 minus 2x to the power of 4 gives this. You know the signs are alternating. Plus, minus, plus, minus, plus, and so on and so forth. So, we are done with part A, which is expanding. So, part B is now hence evaluate 1.98 to the power of 4. Recall again that all you need to do is to simply equate the contents of the bracket to get the actual value of x to be substituted here. So, I'm going to say 1 minus 2x equals to 1.98. That means minus 2x is 1.98 minus 1. So 1.98 minus 1, that should be 0.98. So when you divide that by 2, that gives minus 0.49. That's minus 0.49. That will be the value over our x. Now, let's come back here. We can just say, okay, 1.98 to the power of 4 is equal to what? So we're going to have what? 1 plus 2. What's x? Minus 0.49. Minus 0.49 raised power 4. That's the value. No, so this has to be minus because we compared minus directly. We compared minus, so it has to maintain the minus. Since we compare 1 minus 2s to 1.9, it has to maintain the minus. So if you look at this clearly, if you do this, just mentally do that, you must necessarily get 1.98. Because 2 by 0.49 is 0.98, so 1 plus 0.98 is going to be 1.98. So by simple comparison, we have 1 is there, minus is there, 2, and then x actually minus 0.49. And this becomes, in this formula, 1 minus 8, what's x? Minus 0.49 plus 24 minus 0.49 squared minus 32 minus 0.49 cubed plus 16 minus 0.49 to the power of 4. So that's the actual substitution where you're going to have all true. And at this point, all you need to do is to use your machine or the calculator. I'm going to have 15.3695 approximately to 4 decimal places. And that's how to solve the binomial expansion problem that has to do with evaluating numerical values, which I believe you found quite interesting and fun. If you do, please try to stay tuned, subscribe, share, like, and importantly, tune on your buttons so that you'll be able to know when the next video is going to drop. The next video is going to be on further problems on binomial expansions. Thank you and stay blessed.